Welcome to this introduction to Git and GitHub. I'm Kendra Audeich, and I'm a PhD student in neuroscience at McGill University. I'm making this video for other researchers who want to use Git and GitHub to make their work more efficient, reproducible, and open. I've got some slides on the left to explain concepts, and I've got my bash terminal on the right here where I'll give some examples. I'd just like to recognize that many parts of this presentation are inspired or based on these two great resources, and I'll have more references for specific figures in the video description. I've organized this lecture around our goals. I hope that by the end you'll have a basic understanding of what is distributed version control and why is Git useful, particularly in a research context. I also hope you'll know where to start, if not every command, to track your own work with Git and share your work and collaborate on GitHub. So we'll go through this presentation in the order of these goals. Let's look at what is distributed version control, starting with what is version control in general. Version control tracks changes to files and lets you recall different versions of files. You can see some different versions and the changes that are being tracked in between. Once you have a version control system, it makes your work a lot more efficient and reliable. And it's especially essential when you're doing big collaborative projects because everybody needs to be using the same system for it to work smoothly. You can track almost any type of file, but it works best on text-based files. And we'll come back to this once we've learned a few commands so I can demonstrate to you why Git doesn't work very well for tracking things like Word documents. Now, there are different types of version control, and one type is distributed version control, but let's go through some other ones so that distributed version control makes sense. In local version control, you have a version database on your computer here, and you check out a file to work on still on your computer, and then you store the changes back in the database, making a new version. But many people don't write code in complete isolation, so how do we collaborate? To collaborate, you can use centralized version control, where the version database is on some central remote repository, such as a designated machine in your workplace. And then each user will check out the file they need, edit it, and then push it back to the database. This can actually be quite slow because you continually have to communicate with the server. And also there's the problem of what if the server crashes. This problem is solved in distributed version control, where there's a central database, like before, but each client mirrors the entire repository and its history. You can see that the entire version database is on each individual person's computer as well as on the remote database. It's faster because you need to communicate less with the server, and it also has many benefits for large projects with a lot of collaborators. It allows for multiple remote repositories and nonlinear development, which is something we'll come back to later. Now, Git is just one type of distributed version control. This is a good place to quickly distinguish Git from GitHub. Git is the language that we use to do version control, and GitHub just hosts the Git repository online. So GitHub is just this remote server that has the repository copied on it. So the remote repository could be GitHub, or it could be another website like Bitbucket or GitLab, or it could be an actual computer that's connected through a network. Now we've covered what is distributed version control, so let's talk about why Git in particular is useful, and we'll be focusing here on the context of using Git in research. Let's start with a quick history lesson. This will just help you understand why Git is useful because you'll know where it came from. So Linux is a huge open source software project, and actually the Linux kernel is the basis of the operating system that I'm running on my laptop right now. It's Ubuntu. So from 1991 to 2002, they tracked changes to this huge project using archive files and patches, which they just passed around between collaborators. Then in 2002 until 2005, they used BitKeeper, which is a proprietary distributed version control system. However, in 2005, their relationship went a bit sour and BitKeeper was going to start charging money. So in 2005, Linus Torvalds, who actually created Linux, created a new system for distributed version control. And they wanted it to be simple and fast and fully distributed, but also support nonlinear development because it's such a huge project. And we'll come back to what is nonlinear development later. And it had to be scalable. It had to scale easily to huge projects. But the important thing to take away from this is that Git was created for a huge software project. So it's very efficient, but you probably won't need all of its features. Let's dig a bit deeper into how Git is different and why that makes it useful. So Git offers a different user experience. In other version control systems, the user interacts with information like each version is a sum of the base file, here file A, plus all the subsequent changes. This little triangle, this delta symbol just means change. So if you wanted this version of the file, you would just take the original version and sum it. Now, Git stores a stream of snapshots of a mini file system. It's more like saving a new version of a file at each version. Now, under the hood, it's also storing differences between files, not the same full file all the time, but the way the user interacts with it is different. Now, I'd actually argue that this is a more intuitive user experience, which helps make Git easy to use once you understand it. So this is a famous comic by PhD Comics, and it's a situation probably we've all found ourselves in, where we have a file and we feel like we're done, and then we get comments and we have to do a revision. We get a version back with comments and so on, and each version of this file gets renamed, and it becomes a little ridiculous, and you can't remember which version was which, and so on. So it's more intuitive. Git is more intuitive, I think, because it's you interact with information as if every version of the file is like a new saved version instead of a stream of undos, for example. And obviously Git does this in a way that's much more efficient and reliable than somebody trying to make their own system to do this. Let's just dig a bit deeper into why Git is so useful, looking at why it's reliable. Unlike some other systems, it doesn't rely on file names to keep track of files. This would be problematic if, say, we change the name of the file. What it does is it converts the contents of a file or a directory into a hash, which in this case is 40 hexadecimal characters, so letters and numbers, letters up to a certain part of the alphabet. And it is this hash is unique and deterministic in one direction. So the same contents of a file or a directory will always be converted into the same hash. And if you change the content of a file, you'll get a changed hash. I'm just going to give a quick example of how this works because I know it can be pretty confusing. So if I do ls, over here in my terminal, you can see I have this file called file.txt. I'm just going to open it in Visual Studio Code here, and you'll see that it just says hello world. So let's see what the hash would be for this file with its given contents. So I'm going to do sha1sum. This isn't a git command, it's just the kind of command that Git uses in order to make this type of hash. So I do sha1sum and then the file name, file.txt, and I get this hash. So now let's try changing something in the file and see what happens to the hash. I'm going to save it. Let's do the same command again, and you can see the hash is different than it was before. Let's go back in here and change it back to the way it was and do the command again, and you can see now it's the same as it was initially because the contents of the file are the same as it was initially. So this just demonstrates how it is deterministic. Every time you convert the same contents into this kind of hash, you always get the same hash. So this is how, Git is so reliable in the way that it tracks things. Another demonstration of why Git is useful is just looking at how many people use it. So most developers use Git for version control. There's this survey done by Stack Overflow with many responses over some recent years. And this is a list of different version control systems, and you can see that Git is by far the most commonly used system. So if you're going to do version control, and especially if you're going to collaborate, it's best to learn Git because it's so commonly used. But you might say, Kendra, we're not developers, we are researchers. It's, is it really worth it for me to learn this? Well, are we not developers? If you're doing analyses, you probably write code or you use some kind of graphical user interface where you press buttons for research, and even the GUI, the graphical user interface, is based on code. So we're using code to do our research. And we hopefully want to do our research in a way that is open, reproducible, and collaborative. And I would ask you, do you have your own system that does this? I certainly do not. Not for lack of trying. In my master's, I did try to make my own system, and it was a disaster. So let me just remind you of this comic we looked at before. A lot of the systems we try to make for ourselves for keeping track of versions are not very efficient and not very reliable. Science, after all, aspires to be distributed, open-source knowledge development. This is one of my favorite quotes, and it's from this lecture by Richard McElreath called Science as Amateur Software Development, where he talks about how a lot of our goals in academia and in research are similar to goals in software development, but we don't get comprehensive training on the tools we need in order to do our job well, basically. So another incentive, if you want to do your job well as a scientist, it's important to have some kind of reliable way of tracking and sharing your work. So now we've covered why is Git useful, and I hope I've convinced you that it is useful, even in research. And now let's talk about how to track your own work with Git. These are all the commands that we're going to cover, and I don't put it here to intimidate you. I just want to show you what we're going to be building up to. As we go through each of these commands, we will build up this figure. And keep in mind that you only need a few of these commands to start. I'm pretty sure that when I started, I only used these 4 commands for months before I started to get an intuition of how things worked. So all these other commands, you can actually just look up when you need it. So just keep that in mind if you start to feel overwhelmed. First, let's talk about how to get help. In the terminal, if you know the verb, the Git verb, and you want to know what it does or what are its options, you can use these commands. So there's this Git verb or Git command, verb is the same as command, called Git add, and this is one you'll use a lot. So let's just look at the help doc for Git add. Git help, and then the command, which is add. And you get this manual. It shows you the name. It shows you basically what it does. It shows you a bunch of different options that you have, and then it gives you a more in-depth description, and it goes into all the options. And this all is also online if you find it weird to be reading these things in the terminal. And just a tip, press Q to exit this. There we go. And really, the main thing you should do is just Google it, because probably for most of the questions you'll have, someone else has had that question and somebody has answered it for them. So just Google things. So the first thing to understand is that there are 3 file states. So a file can be in the modified state, where you have made a change to the file. It can be staged, which just means that you indicated that you want the modified file in your next snapshot. So think of this as putting people in place for a photo. And then committed means you have actually taken the snapshot of the change. These three file states correspond to the three parts of a Git project on your machine. So first we have the working directory here, which is where you make changes. It is the version of the project that you're working on. Next we have the staging area or index, where you put what will be in your next snapshot. So these aren't tracked changes yet. You've just indicated that you want to track the changes. And then finally, you have the local repository, which is where there are metadata and objects that make up the actual snapshots. So we won't go into exactly what those metadata and objects are, but I just want to reiterate that the only thing that makes a repository a folder a Git repository is just that it has this .git subfolder. So here, if we look at the contents of this directory with the -a option in order to look at hidden files, you can see that there's this .git subfolder, and that's what makes this a Git repository. This also corresponds to a three-step basic workflow, and I'm repeating these similar concepts in slightly different ways so that it really sinks in, because this is a very important part of using Git. So first in this workflow, you change a file in your working tree, so that's in this working directory here. Then you stage the file by using the command git add and then the file name. And this, in terms of Git, moves it into the staging area. And finally, git commit, when you actually take the snapshot, you use the command git commit, and then -m is the option you use to add this short and informative commit message right in the command line. And it's really important that you use a commit message that is informative so that later when you look through your commits, and I'll show you how to do that in a bit, but when you look through your commits, you want to actually know what you did at which commit so you can go back and change things if you need to. So again, git add is just getting things on stage ready to be committed, but it's not actually committed yet. And then git commit is actually taking the snapshot. I'll just do a quick demo to show how this works. So let's look in the directory I'm in right now. You can see that it is a Git repository, and I have this file called file.txt, and I'm going to edit it. So I'll open it in VS Code, and I'm going to add Kendra. Let's add I'm Kendra and save it. And then I'm going to do git add and then the file name. Oops. And then commit it with git commit, then the option -m so I can add the commit message right in the command line. And let's see, I added a line for demonstration. So, and Git has this neat feature where after you do something, it kind of like tells you what you did. And this is really helpful for catching mistakes, and you'll see other examples of the output of Git being very useful. Now, how do you actually start a Git repo? I talked about making a change before doing this, even though you actually have to start the Git repo before you can track changes, just because I needed to talk about making a change before you could understand these different parts of the Git repo. So there are two options for starting a Git repo. First, you can clone an existing repo from a remote place, for example, from GitHub. In this cloud here, I have GitHub. So you can clone it to your computer, or you can make an existing folder into a repo. So you just change into the directory that you want to be a Git repo, and you just run the command git init. And I'll do a quick demo again. If I go up a folder into my teaching folder, I can make a folder called temp, which I'll delete later, which is why I'm calling it temp. And I'm going to change directories into it. And then if I do ls-a, you see there's nothing in it. This is just kind of shortcuts for the current directory and the parent directory, but there's essentially nothing in it. And then I do git init, and then I look at what is in it, and you can see now it has this .git folder. And again, Git kind of tells you what you did after you did it, which is really nice. Now we're going to talk about inspecting what's going on with Git. So these are really useful commands that don't do anything. So you can use them as much as you want, and you don't have to worry about messing anything up. So first we have git status, which lets you check the status of the files in your repo. Basically, it tells you which files are in which position here. And I'll demonstrate this in a second. To actually see what changed, you can use git diff. And to see the history of your repo, you can use git log. So now I'm just going to give a demo of all these commands in the context of the workflow that I did previously. So first let's do git log. You can see the previous commits that I've made, identified by their unique hash. And again, like I said, each file is made into a hash for Git to keep track of it. And all of the files hashes are then hashed, and that is the commit hash for all the changes that happened in that commit. So we can see the author and the date of the commit, as well as the message that I gave during my commit command. And let's do git status now. This shows you the status of the repo. So it tells you we're on the branch called master. We'll talk more about branches later. But it tells you essentially there is nothing to commit. The working tree is clean. There are no changes here. There are no differences between this working directory and what's been tracked in the local repo. Now let's make a change and see how git status gives different output. So looking in our directory, you can see we have this file. Let's open it. And make a change. I love winter. And save it. Yes, I am a true Canadian. Now let's do git status. You can see now that, again, we're on this branch, and there are changes that have not been staged yet for commit. And this is the file that's been modified. So Git, again, is really helpful. It tells you what you can do in order to add more files to update what will be committed. And if you want to discard this change, you can do git restore. But we'll talk more about undoing things later. So let's commit it, or add it. Yes, we have not added it yet. We will use git add in order to stage the change. Now let's do git status again. And now you can see it's green, and it says that it's listed under changes to be committed. That means it's ready to be committed. If we had done a commit at this point, nothing would have happened because there were no files ready to be committed. So let's do git commit with a commit message. Added that I love winter. And again, Git tells you what you did. And let's do git status. Once again, there's nothing to commit. The working tree is clean because we've taken a snapshot of all the changes that we made. So now let's do git log. And you can see that there's now 3 commits. And the latest one is at the top. This is the one where I added that I love winter. And that is basically how you can use these commands. And again, really when I started, I used git add, git commit, and one more that I'll talk about called git push and git status. And those were the 4 that I used for months without worrying about the other ones. So don't get overwhelmed. Now we know enough commands to demonstrate how Git is not so suited for tracking things like documents, like Word documents or open document format documents, and how it's better suited to tracking things like text files. So in my current directory here, I have 2 files. One is open document format and the other is a text file, and I'll just open both of those up. And you can see that they both have the same text inside them. And I'll add a line to each of them. I'm Canadian, save. Okay, and I'll minimize those. Now let's see what the git diff is like for each of these files. First, I'll do git status just to show you. I've changed both of these. I have not added them yet. They're not staged for commit. This is just a temporary file because I still have the document open. Just ignore that. If I do git diff and then file.txt, you'll see that Git can conveniently tell me that I added this line, I'm Canadian. On the other hand, if I could git diff and then I do file.odt, it just says that binary files, these files differ. This is the version, one is the version that's been last committed in the local repo, and the other is the version in my current directory. All it knows is that they differ. It doesn't know exactly which words differ within the file. That's because if we actually cat the contents of this file, you can see it looks a bit like gibberish. For something that's based on text and is meant to understand files based on simple text, this type of format is difficult to track. Whereas if I cat the contents of the file .text, you can see it understands what's going on, and it just gives me the contents that I'm expecting. So this is just to re-emphasize that Git isn't ideal for tracking things like Word documents. Let's go over some common undoing goals, some common reasons why you'd want to undo something. So first, if you want to unmodify a file, you can do git restore and then the file, or git checkout -- and then the file. So that's when something's been modified in your directory, it hasn't been staged, has not been committed, you just want to undo the changes. Basically, you're restoring the file to the last snapshot. So another thing you might want to do is unstage a file. Say you've already done git add and you want to unstage it. You can do git restore -- staged or git reset head and then the file. And an important difference is when you unmodify a file, obviously you're undoing the changes in your working directory, so you're losing information. But if you unstage something, you're just going to stop Git from being ready to commit it. So you still have the changes here. That's why I marked this in red. It's a little more dangerous. Say you forgot a file in the last commit. You can do git add the file. So you add the file so it's staged and ready to be committed. And then you do git commit -- amend. And you don't need a new commit message because you're just amending the last commit, saying, I forgot this file, add it. Or I forgot all of the changes that have been staged, which in this case is only one file. Please commit those changes. And finally, if you want to just undo the last commit, you can do git reset and then head and this little tilde, and this will undo the last commit. If you want to completely delete the last commit, you're just going to add the option -- hard. So quick little demo here, and I'm going to go through this a bit faster without explaining everything because we've done it a few times. I'm going to open the file we've been working on. I'm going to add another line and save it, and then do git status. You can see that it's not staged for commit right now. I'm going to unmodify it with git restore file. And if I look at it again, you can see that what the change I'd made is now gone. So let's just put that change in there again. Save it. Git status. We're in the same position as before, but now let's git add it. And if we want to now unstage it, you can see it's staged, it's ready to be committed. Now we can do git restore -- staged, and then the file, and do git status again. And you can see that now it's at the stage of being in my working directory. And if we open it, we'll see the change is still there, it just is no longer staged. So that's why this is less dangerous. You still have the change, it's just no longer staged. So let's just add it again. Let's commit it. And if I do git log, you can see now I have this additional commit. Say I just want to completely delete that commit, rewrite history. I can do git reset hard, and then head. And now I do git log. You can see it's as if I never made that last commit. Undoing can feel a bit intimidating at first, so here are a few tips. Don't try to memorize all these commands like I've been saying over and over. You won't have to do undo major things very often. You can always look up. Like, I literally just looked up how to delete a commit. Also, you can try it out in a sandbox repo first. You can make a repo that doesn't really matter, like this one, and just make some files and see what happens when you run a certain sequence of commands. You can also use git checkout and then a commit hash -b and a branch name, and this combination of commands starts a new branch at the point you want to revert to in order to see what it would be like. So we haven't talked about branches yet, so this might not make sense, but if you're coming back to this slide later, that's one option. For minor recent fixes, you can try just reading the output of git status if you can't remember what to do. Again, oops, there we go. Again, if I make a change, blah, and I do git status, it gives this helpful output telling you what you could do, say to undo what you just did. That would be git restore, blah, blah, blah. Also, just look it up. Somebody has probably had your question before. Google is your friend. Now, at last, let's talk about branches. And I have to warn you, branches can be a bit confusing at first, especially because I'm going to use a slightly different diagram than we've been using so far. But you don't actually have to use branches at first when you're starting, when you're just tracking your own work. So feel free to zone out and come back to this when you're ready. So branches are really what you need in order to do nonlinear development, which is something I've mentioned a few times. So to give a sense for why we need this, consider Linux. In the past month, over 1,000 authors have pushed over 5,000 commits to the Linux GitHub repository. And this is a lot of changes, and you can imagine they couldn't have done this in a linear way where each author kind of waited for their turn to make a commit. No, a lot of these changes are happening at the same time, and in that way it's nonlinear. So here is that figure, which is deceptively similar looking to the other figure, but is completely different. Let me explain it. So each row is a different branch. You can see this one is named master. So remember when I did git status, oops, it told me I was on branch master. So this is the default branch. So somebody was working on branch master, and then a new branch was opened where they're working on something else. They named the branch develop, and you can see they had a series of commits here. Then they merged into this other branch called release, and had 2 commits there, and then they merged back into master. So this is a great way to try something new, say develop a new feature, or try a new step in your code, and you can try it out without worrying about messing up this branch. And it's really important when you're collaborating, because say this was a software project, maybe it's like NiLearn, which is a popular neuroimaging software in Python. They want to make sure the master branch is always working, the main branch is always working, so that people using the software don't run into problems. But obviously they are going to be fixing bugs and developing new features, and they can do this on branches, make sure it works, and then merge it back into the master branch once they're sure that it works. And little tip, actually GitHub has a great way of viewing a project's network. Calling this a network, where each node is a commit here. So this is a GitHub repository that I was helping out with to create a tutorial for a conference a while ago. So if I go to Insights, and my internet is a little slow, I apologize, and then Network, you can see something really similar to this figure here, but for this particular repo. So this is the main branch, and Taylor was the principal maintainer, so he's just committing on master here. You can see all of his commits. And then here you can see I did a few things on a different branch, and then it was merged there. And here I did another thing, and then it was merged. Yeah, so that's a really great way of visualizing it. There's many ways of visualizing this. This is, in my experience, just the most convenient if you have a remote repo on GitHub. Now, just a quick clarification between branches and tags, because they're kind of similar, but used for different purposes. So a branch marks a line of development. Here it's a branch. For example, a new feature or a collaborator's contribution. A tag marks an important point in history. So these little boxes here are tags. They're like stickers that are just stuck on a point in history with an important identifier. For example, a software version. Now, what is it exactly? Just going into the underworkings a little bit. A branch is just a text file where the file name is the branch name, and the contents are just the commit hash for the latest commit in that branch. So in the master branch, the file would be called master, and the contents would be the commit hash for this commit, because that's the latest commit. For the tag, it's similar. The file name is the tag name, but the commit hash is always the commit for when the tag was created. So it always sticks with a certain commit. Now let's go into some commands that are useful for working with branches. First, to see which branch you're on, you can just use git branch. To start a new branch, you can do git branch and then the branch name. And to change branches, you just do git checkout and then the branch name. And then if you make changes and you want to merge it into another branch, you do git merge and then the branch name. So you make sure you're on, for example, the master branch. And then if you want to merge release into master, you do git merge release. Now we'll do a quick demo. If I do git branch here, it only lists one branch because I only have one branch in this repository at the moment, and it tells me that I'm on the branch master. If I start a new branch, let's say I want to start a new branch, or I'm going to start talking about desserts in that file. I'll call the branch desserts. And now if I do git branch, you can see it lists 2 branches, and I'm still on branch master. That's marked with a star, and it's in green. So now to change branches, I do git checkout desserts. Now it tells me what I did, and it, if I do git branch again, it'll tell me that now I'm on desserts. Yay! So let's do git status. There was this change that I made. I think I just added blah. Let's just get rid of those changes because they weren't important. So right now it's in the modified state of the working directory. It hasn't been staged. So let's just do git restore file.txt. And now that's gone. So you might think I could have just backspaced it, but I'm just demonstrating once you've made more complicated changes, it'll be harder to remember exactly what you changed. So it's useful to see this command once in a while. So now let's add something. I'm going to add some of my favorite desserts. I like cookies, ice cream, oops, and spekulas. Save. I guess spekulas is a kind of cookie, but whatever. Git status. You can see now I'm on branch desserts. I have a change that's not staged. Let's add it, which means I'm staging it. Add file.txt. Let's do git status just to see. Now it's ready to be committed. Git commit added favorite desserts. So now if I do git status, there are no changes on the working tree. So now let's go back to master. Now I'm on desserts. Let's go back to master. So it was as if I went here, and now I want to go back to master. So I'm going to do git checkout master. Now we're on master. So you can see those desserts are not here because I added them on a different branch. So now let's merge the desserts branch into master. Git merge desserts. Okay, so now it's telling me what it changed, which is super helpful. It added some lines and erased some lines. Let's see what happened. Now it's in the state that it was in the other branch because I merged them together. If I do git log, you can see it's part of my log here on master and part of the log for desserts. Let's just see these commands on the more familiar figure. Branch and checkout just add a new branch and move to a branch. It's a little less intuitive on this figure what it actually does, but just for completeness, I added it here. Now back to our goals. Hopefully you have an idea of how to track your own work with Git. And now we'll move on to how to share your work and collaborate on GitHub. Let's talk about remotes. You've seen this figure already before, and I might have mentioned the word remote a few times. A remote is just a version of the repository. It's a copy of the repository that's in a remote location. So this remote repository could be on a server computer, it could be online on GitHub, Bitbucket, or GitLab. And again, it's just a remote copy of the local repository, and all of the collaborators check into this remote repo. With Git, you can also have, or with distributed version control, you can have multiple remotes. Say you could have one on a computer in your office for the people you work with immediately, but you could also have a remote repo on GitHub where you share your work with other people, and you can have this hierarchical setup. There are lots of possibilities with distributed version control. Don't be intimidated by all the possibilities, though, because really to start, you can just have a GitHub repo mirroring your local repo, even if you're not collaborating with anyone, and it makes it really simple. So let's go over a few commands. Git remote -v just shows your remote repos and the addresses of those remote repos. You can add a remote repo using git remote add and then the remote name and then the remote address. You can push commits to a remote repo using git push and then the remote name and then the branch name you want to push. You can fetch commits from a remote repo, for example, changes made by a collaborator using git fetch and then the remote name. And you can merge those fetched commits from a remote repo using git merge remote name /branch. And we already used the git merge command. So I just want to reiterate for these commands and for most git commands, there's lots of possibilities of what you can do with them. Honestly, I would just suggest looking up what you want to do, and somebody will have asked it and answered it. Here we can see those commands on the familiar figure that we've been using, and I'll talk about them as I demonstrate how to use them. So first, if we want to link our local repository, mine is called Git Sandbox, a repository on GitHub, what I would do if I already had the repo on my computer is I would go to my GitHub account and I would click on repositories. And then I would click new. And for simplicity's sake, I'm going to name it the same thing as my initial repository, Git Sandbox. I will just say a sandbox repo for demonstrating using Git and GitHub. I'm going to make it public because I don't really mind. I'll just delete it later. And an important thing is not to add any of these files. Helpfully here it says skip this step if you're importing an existing repository. The thing is, if we create these files when we create the repository on GitHub and then we try to link it to our local repository, we won't be able to merge the two because they will have different histories. So once they're linked, we can change one and then merge them together. But initially, they have to have the same history. So for now, we want to make an empty repository. So leave all these empty and then click Create Repository. And my internet is extremely slow. This brings us to this page here. And what we're going to do is push an existing repository from the command line. So I'm just going to copy this using this button, and then I will paste it here. And what this is doing is adding a remote called origin at this address, and it might look a bit different from you. I use SSH to connect. You might just have the URL here. And I'm renaming the principal branch to main because now the default for GitHub is that the principal branch will be main, not master. And then I push all of the commits I've made so far to the remote called origin. Again, I just added this remote, called it origin, and gave it this address. So I'm pushing everything there, and the thing that I'm pushing is everything on the main branch. So now when I go to the repo by clicking here, let's just wait for it to load. Now it's loaded, and you can see that I am on the branch main. There's only one branch here because I only pushed one branch. And I have the two files. that are in my repository here. Now if we go back to this figure, we can understand what we did before. So we use git remote, add origin, and then the URL to link our local repo to our remote repo. Now if we do git remote -v, we can see that we have this remote called origin, and this is its address, and it's the same remote for fetching and pushing. You could have different remotes for fetching and pushing. And we pushed our changes locally to the remote repo with git push origin main. So that means we want to push we want to push to origin, the remote called origin, and what we want to push is the main branch. Now let's talk about collaborating and contributing on GitHub, which is really what remotes are good for. Well, they're good for just sharing your work as well, but they're great for collaborating. So first of all, forks. A fork is like a clone, but on GitHub. Most collaborators on a project will have their own fork where they work. So there will be the main repository, and then every collaborator will have their own fork, and they'll push their work to that fork. So here you can see what the basic flow would be is here's this other remote repository. Say this is like, say it's a open software you want to contribute to, like Nylearn, neuroimaging software. So you would fork the main repository. Sorry, I shouldn't use main, that's a name for a branch. You fork the original Nylearn repository so that you have your own copy on GitHub. And then you clone that repository and start a new branch. And on that branch, you add and make changes and add and commit them, and then push those changes to your remote repository. And we have this separation here, which is a little confusing, but very useful, because in this way, you can push changes and they can be reviewed effectively before being integrated into the remote repository. And the way that you will have those changes reviewed is through pull requests. So what you do is you push your commits to your own fork, and then you open a pull request. This allows the project maintainers to review your code or whatever it is you're pushing, make suggestions or edits, and decide whether or not to merge it into the original repository. So here we have this additional step here of a pull request. So once again, you fork the repository, clone it to your computer, start your own branch, do changes, add, commit, and push changes, and then open a pull request. Now the way that you'll find a problem to work on or let the maintainers know what problem you're working on is with an issue. So issues can be used to report problems, even on repositories that you're not collaborating on. Say you're using a software and you run into a problem, you can report it with an issue, and I'll show you what an issue is in a moment. You can also use an issue to propose some new feature on a software package or like on a project you're collaborating on. Or you can say, I want to contribute to this project, and then look through the issues to find something to work on, and then work on it. So now I'm going to demonstrate those 3 features of GitHub. Those features, again, we're forking to make a copy of a remote repo on your own GitHub account. Pull requests, where you want to ask the original remote repo, hey, do you want to incorporate these changes that I made? And issues, which are what you use to find things to work on or propose things to work on. So let's, as an example, go to the GitHub page for Nylearn, which is a package that does machine learning for imaging, neuroimaging in Python. So say I want to contribute to Nylearn. What I'm going to do is make a fork. Now I've already made a fork, so let's just go to my fork. But if you hadn't made a fork, it would create it and then bring you to the fork, just like this. So now I'm on my fork, and I can tell because it has this symbol here saying it's a fork, and it tells me where it is forked from. So that's how forking works. So a next step could be to find something to work on. And to do that, I would go to the main repository, the original repository. And if this is my first time, I would first look for a file called contributing, where I'd find the guidelines for how to contribute to this particular package. Then I would go to issues and find an issue to work on. So each of these is an issue. They've been given labels to kind of help categorize issues. So say you wanted to fix a bug, you could look for the label bug. And these are all things that people are reporting as needing fixing. Or say you don't actually want to work on code, you could search for documentation. Maybe there's some problems with the documentation that you can do. Like here it's saying this is not clear. So maybe you can clarify the docs. A good first place to start is with the label good first issue. This is, good first issue. Oh, see, now I have all three checked. There we go. So you can look for combos of labels as I just inadvertently demonstrated. So now I'm just looking for the label good first issue. And these are all issues people have marked as being good for newcomers. And say I want to work on plotting. This looks promising. Somebody summarized what the issue is about in the title. They give a little more details here. People are commenting on it and having a discussion. And you would read the discussion basically to see is someone already looking on this. You can also look for assignees if someone has been assigned to work on it. And if you think you could fix the problem or do the enhancement or whatever it is, you could say here, hey, can I work on this? Or whatever you want to say to let the project maintainers know that you're interested. And then you get the go-ahead to work on it, and you can start working on it. Now we have something to work on, and the next step will be to go to our own fork and download the code onto our machine so we can start working on it. So we do that by clicking this download code button and then select the type of clone you want to do. I'm using SSH to communicate with GitHub, so I'm just going to copy that. And then I'm going to go to my terminal. I'm going to navigate to a location where I want this new repository to be. I'm going to go to my projects folder, and now we can clone the repo to our computer so that we will have a local copy. So we did fork, and now we're going to clone our fork with git clone, and then the repo address on GitHub. Again, this is our fork, and I'm cloning it to my computer, and now Git has made a folder called Nylearn, and you can see I have all the contents of the Nylearn folder. Now the next step is to start our own branch. So you can see branch. Right now there's only one called master, so let's make one to work on. And the issue we're working on, let's just go back to it because we want to name our branch something informative, is about supporting 4D images for plot ROI. So maybe I'll call it 4D plot ROI. Actually, I don't know. Git branch. There we go. So now I can move on to that branch. and make my change, and then add the changes, and then commit with a informative message. And something that's really cool about GitHub is if you reference the issue in your commit, then it'll automatically generate this message here saying Kendra opened a pull request related to this issue. So I could write something like addresses, and then the number sign. Number sign indicates you're going to reference an issue, and then 2721. I'm not going to actually commit because I have nothing to commit right now. But you get the idea. Now if I'm ready to share my changes, I can push them to my fork with git push origin and then the name of the branch. And then I can go to my fork, which is here, and a little pop-up here would say, do you want to open a pull request? And I would say yes, and then the maintainers of the project would be notified, and there would be a message here saying somebody opened a pull request related to this issue. Now, if I want to get changes made by others, I can add another remote with the address from the original repo. So right now, if I go over here and look at the remotes that I have, you can see I just have origin, and that's the address of my fork. I can add another one, git remote add, and I'm going to call it upstream because that's the conventional name for the original repository. That's not my fork. And then I will just paste this here. And now when I do git remote -v again, you can see I have two different GitHub repositories that I can fetch from and push to. And what I would want to do is push to my fork and fetch from the upstream in order to contribute my changes and get changes from other people. So it's a little bit confusing. Don't worry if you don't understand it right away. It kind of sinks in once you've started to do it a few times. At some point when you're using Git, and especially if you're using GitHub, you'll probably run into merge conflicts. These happen when you're trying to merge two versions of the same file, for example, where the changes that have been made in those two versions are incompatible, so you have a conflict. Now to show this, I first want to show you how Git tracks differences so you can understand when this might happen. To do this, let's go back to our file and add something here. But I like swimming, and save it. Oops. There we go. Now if I do git diff, we're going to see that I added this line, but I like swimming. Let's add it. Okay, so we added and committed it. Now let's change it again, just a little bit on the same line, and save that. And now we're going to do git diff again. And you can see that it recorded, I just added one word, but it recorded it as if I deleted that line and added a new line with a lot at the end. So basically Git is tracking line by line, and if you have two changes on the same line that are coming from different sources, it'll cause a merge conflict. What if several people edit the same line of code? This could lead to a merge conflict, and someone would need to manually resolve it. In order to demonstrate this, I'm going to use a figure here and actually go through the steps here so you can really let it sink in when merge conflicts would occur. So here I'm on the branch main. I make a commit where I add a file called colors.txt, and the contents of the file are just the word red. So let's do that here. Let's check out which branch we're on. So git branch. I'm on the main branch. That's great. Now let's make a file. I'm just entering the name of my text editor and then the name of the file that I want to create. So this will create the file and open it in Virtual Studio Code. I'm going to enter the contents and save it. And then I am going to do git status just to show you. I have this file that's not yet tracked. Add colors. So now I am staging the change. Now if I do git status, you can see that I have changes that are ready to be committed. At this point, they were not staged, so I could not have committed the changes. Now I can commit them. Git commit with this message. I'm just going to make the commit messages for this colors file the contents, just so it's easy when we look through the log later to see which commits did what. So just red. Now we're going to start a new branch where we change the file by adding the color blue. So again, git branch, we're on the main branch. Let's add a new branch called new branch. So you can see we've added it, it's here, but we're not on it. So now let's change to that branch, git checkout, new branch. See, now we are on the new branch. Great, let's edit this file. I'll do code colors.txt because the file already exists. It's not going to create it again. It's just going to open it. And let's add blue. Save. Git status. You can see we're on the branch, new branch, which actually is not a very good name for a branch. Don't name your branches new branch. Try something more informative. Anyways, we're on this new branch. There are changes that are not staged. So if we made a commit now, they would not be committed because they're not staged. So let's add them so they're staged. Git add colors.txt. Now I do git status again. You can see that now there are changes that are ready to be committed. So let's do git commit. And for the commit message, I'm just going to do, again, the contents of the file so that we can remember well. Oops. Sorry about that. Oh. There we go. All right, now I do git status again. We're on this branch. There's nothing to commit. What's next? So then, but back on the main branch, say someone else is working on the main branch. Someone adds the color green under the color red. So let's check out the main branch and do that change. And this is really handy. Git tells us that your branch is ahead of origin main by one commit. So that's the remote repo. So it's telling us that this branch we just made is ahead of origin, the remote called origin, and the branch main. So here we go. Now we're on main. Let's just pull up that file. Look, blue is not there because we added blue on this new branch and we're on the main branch. So let's add green and save it. Now if I do git status, you can see these changes I just made are not staged for commit. I have to stage them with git add colors.txt, and then I can commit them. Red, green. All right, so just think for a sec. What do you think would happen if I did git log? Would I see all three of these commits? Remember, right now I'm on the main branch. So let's see, git log. These are previous commits. You can just ignore them. Red was the first commit, and then I have red, green. But you can see I don't have the red, blue commit. Let's quit that with the letter Q, and I'll use Control L to clear the screen there. What's next? Well, next we want to merge the new branch into the main branch, and this is going to result in a merge conflict, and I'll explain that in a second. So let's see. We're on the main branch, and we want to merge the new branch into it. So I do git merge new branch. And it tells you there was a conflict. So we have to open the file to see what the conflict was, and you can see this exactly what's here. So it's telling you that this is where we are now. This is the current change on the main branch that we're on. And the incoming change from the other branch, called new branch, is blue, and they're on the same line, so we have to pick one. Or we can edit it further and add them both, but if we can only accept one contributor's edits, then we have to pick one. So let's say we actually want to accept this, what was on the new branch. We're going to do accept incoming change. And this will look a little bit different in different text editors. It looks a little different if you do this merging on GitHub, for example, in a pull request. But the basic idea is the same. It'll tell you you have a merge conflict, it'll tell you where, and it'll give you a choice of what to accept. So let's see, git status. So right now we have unmerged paths. We just merged it in this file, but we haven't added or committed that resolution of the merge. So let's do that. Git add colors.text. Git status. Now it's ready to be committed. So and it handily tells us that all conflicts are fixed, but you're still merging. So we still have to finish our commit in order to actually merge it. So let's do git commit, merge, new branch. Let's say we accept blue instead of green. Now if I do git log, you can see that both branches have been merged, so we see all of the commits. We see the initial commit here, which was there. We see the commit we made on new branch, which was there. And then we see the commit that we made, again, on the main branch here. And we see the merge. And we can see that's where we are now. We're on the main branch at this point. This was the latest change. And that's how you create and resolve a merge conflict. Not that you would want to create one, but if you see how to create it, then it'll help to avoid it or know how to resolve it. Now we come back to our goals. We've covered all of our goals, just now ending with how to share your work and collaborate on GitHub. And I just want to leave you with some final tips. Git can become really powerful with options. Most of the commands I showed you, I showed in their basic format, or close to the very basic format. So if I just do git log, we see the standard format for the log. However, if I add an option, say I add the option git log -- graph, it gives me this kind of illustration of the graph. And I added this figure here just to show this is Git's attempt to do this kind of graph, but in the command line. So you can see the main branch here in green. At this point, I made a new branch, and that's shown in red. And then I made another commit on the main branch here, and then I merged them there. And if I can customize it even more if I want by adding this pretty format option where I specify the format I want to see the information in. So I do git log pretty format, and then I give the format I want it in. First I want the hash, then I want a dash, then the author's name, then I want a comma, then I want the date, and then a colon, and then I want the commit message, and I want the graph. So you can see now it's a little more compact, a little easier to read, and gives the same information. And actually, you might be asking, how on earth will I remember that? You can set aliases for commands that you use a lot. So I made an alias for this called fancy log. So I added to my git config file this alias, which I called fancy log, and then in single quotes here I have the command that I want to be aliased as fancy log. So now when I do git fancy log, it shows me the same thing. So this is just to show you some possibilities as you start to work more with Git. You can learn more about the different options, and you can customize your workflow by using these aliases. So my final tip is pick a bite-sized amount to start with. Everything else you can look up when you need it. I highly suggest just working on your own at first to get used to it. And really all you need is git add, commit, push, and status to kind of establish a basic workflow. When I started, I literally put these on a sticky note beside my computer because I was annoyed with always having to look them up. And really anything else you can just look up when you need it. And that is the end. I hope you've learned a lot. Once again, I used the book Pro Git and the tutorial by Software Carpentries to learn more about Git, and I based a lot of this on those. Some of my figures are from those resources, and I'll put all the figure references in the YouTube video description. Thanks so much, and hope that helped.